Hey guys, welcome to this session. Our topic is formula bonding and nomenclature. So this is a new topic whereby we'll be discussing about the bonding of the various elements. That means the combination of the elements to form various compounds. Now, and we'll start seeing first about the valence. So this is our first subtopic which we are going to discuss in this topic. Now, we have to know the concept of this valence. Valence simply is the capability or just the ability of an atom to combine with one or more atoms to form a molecular compound. So that kind of ability of an atom that is given to them, whereby it can combine with the one or more other atoms to just form a molecular compound, is what we call the valence. Now, also valence can also be referred to as the number of electrons that an atom can gain, lose, or share in forming a chemical bond with another atom. So that kind of a number of various electrons, which are just the negatively charged ions that an atom can gain, lose, or share in forming a chemical bond with another atom is what we call the valence. Now, the valence, or we can simply call a combining power, depends on the number of the electrons that are in the outermost orbit or the outermost shell or the valence shell that is formed in the formation of a chemical bond. The number of the electrons in the valence shell is never greater than 7, so it is less than 7, and the outermost electronic configuration is which is responsible for the variability of the various valences of the atom. Now, some elements exhibit more than one valence. This means they will variable variance. Examples of these elements with the variable variance are like iron that has 2 and 3, tin that has 2 and 4, and the copper that has 1 and 2. Now, let's see also the concept of this valence and the oxidation states. Now, there's a strong correlation or a relationship between this valence and the oxidation state. The oxidation state of an element simply equals its valence or charge carried by its ion when an element ionizes in solution. Take an example of this kind of a relation is the iron 2, whose oxidation state or the oxidation number is 2 and its valence is 2. The same that applies to iron 3, whereby the oxidation state or the oxidation number is 3 and its valence is the 3. Now, other elements with the variable valences, they include such as the copper 1 and copper 2 that have oxidation state equal to 1 and 2 respectively. Now, you have to note that the valence of the common transition elements should be memorized since they can differ by one another, and the valences of the normal elements may be deduced from the group number they occupy in simply in their periodic table. The valences of elements of group 1 to 4 are equal to the group numbers they occupy in the periodic table. So the valences of elements that are in group 1 will occupy the valence that is 1. The same goes to 2, will occupy 2, 3, also 3, and 4 will also occupy 4. So the valence of these elements that are in these groups from 1 to 4 are just equal to the group numbers they occupy in this periodic table. Now the valence of the element in group 5 to 8 is equal simply to just 8 minus the group number. Take an example, the valence of chlorine, which is in group 7, is 1. This means you take 8 minus 7, you get 1. So the valence of chlorine is 1. Then the valence of oxygen that is in group 6 is 2. This means that you take 8 minus 6, you get 2. Also, the elements in the group O, that is group 8, have 0 valence. Simply when you take 8 minus 8, that is equal to 0. So I hope it's clear, guys. Thank you for listening. In this video, we introduced this new topic, the formula bonding and nomenclature. We've started seeing the valence. We've discussed the concept of valence, that is the uh, bonding power, and we've discussed the how it relates to the oxidation state of an atom. So thank you, and in our next video, we'll discuss more on the chemical formula. Thank you.